Hello and welcome to the Magic of Mathematics channel. My name is Manohar Murthy and you are watching one amongst a series of videos exploring the world of mathematics. In this video, I intend to present an intuitive explanation of the method used to compare two fractions. I will assume here that you know what a fraction is and how to represent it visually. I will also assume that you are familiar with the concept of common multiples and the least common multiple. Let us assume that we have to compare the fractions 4 by 7 and 3 by 4 to see which represents a greater or larger quantity and which represents a lesser or smaller quantity. Let us represent these two fractions visually. For this, let us take two identical chocolates as shown. If we divide the first chocolate into 7 equal pieces, the 4 pieces as marked represent 4 by 7. Similarly, we can divide the second chocolate into 4 equal pieces as shown. And if we do this, the 3 pieces as marked represent 3 by 4. Just by looking at this visual representation, it is clear that the quantity of chocolate that we have marked out in the second case is larger than the quantity that we have marked out in the first case. Hence, we can say that 3 by 4 is greater than 4 by 7. From what we have seen so far, it is clear that if we visually represent two fractions side by side, we can compare them. However, it is not always practical to compare using this approach, since we can't be drawing visual representations each time we want to compare two fractions. Even if we are okay drawing visual representations, this technique may not work for fractions which are almost equal. Hence, we need a more practical approach for comparing two fractions. Let us now try to intuitively come up with this approach. We have seen that 4 by 7 represents 4 pieces of chocolate of the size obtained by cutting a chocolate into 7 equal pieces, whereas 3 by 4 represents 3 pieces of chocolate of the size obtained by cutting a chocolate into 4 equal pieces. Since we have cut the chocolate into more number of pieces in the first case as compared to the second case, we can see that the pieces in the first case are smaller in size than the pieces in the second case. Had the piece size been same in both the cases, we could have said that the fraction representing more number of pieces is greater than the fraction representing less number of pieces. But it is obvious that we can't apply this logic here as the piece size is different in both the cases. To get around this problem, I will make the piece size same in both the cases without disturbing the fraction value. Or, in other words, I will make the number of equal size pieces into which we cut the chocolate in each case the same. For this, I will take the pieces as seen here and cut each of them further into equal size pieces. If we cut each of the 7 equal size pieces of the first chocolate into 2 equal size pieces each, we will end up with a total of 2 times 7 equal size pieces. Cutting the 7 pieces into 3 equal size pieces instead will give us 3 times 7 equal size pieces. Cutting them into 4 pieces instead will give us 4 times 7 equal size pieces, and so on. Doing the same exercise for the second chocolate will give us 2 times 4 pieces, 3 times 4 pieces, 4 times 4 pieces, 5 times 4 pieces, 6 times 4 pieces, 7 times 4 pieces, and so on. We can clearly see that if we cut each of the 7 equal size pieces of the first chocolate into 4 equal pieces, we get a total of 4 times 7 equal size pieces. Similarly, cutting each of the 4 equal size pieces of the second chocolate into 7 equal size pieces results in a total of 7 times 4 equal size pieces. Since 4 times 7 is equal to 7 times 4, cutting the chocolates in this manner results in the same number of equal size pieces and hence the same piece size in both the cases. And this is what we wanted. It is clear that 4 times 7, which is equal to 7 times 4, is a common multiple of the denominators 7 and 4 of our two fractions, namely 4 by 7 and 3 by 4. In fact, 4 times 7 or 7 times 4 is the LCM of the two denominators. If we cut each of the 7 pieces of the first chocolate into 4 equal size pieces, thereby resulting in 4 times 7 equal pieces, our original 4 pieces would become 4 times 4 pieces of the new size. In other words, we have converted our original fraction into an equivalent fraction, namely 4 times 4 by 4 times 7. Doing a similar exercise with our second fraction would yield an equivalent fraction, namely 7 times 3 by 7 times 4. The first fraction now represents 4 times 4 pieces, which is equal to 16 pieces of the size obtained by cutting a chocolate into 4 times 7 equal pieces, that is 28 equal size pieces. Similarly, the second fraction represents 21 pieces of the size obtained by cutting a chocolate into 28 equal size pieces. Now that the piece size is same in both the cases, we can compare the number of pieces in both the cases, and since the second fraction represents more number of pieces as compared to the first fraction, we can say that the second fraction, namely 21 by 28, is greater than the first fraction, namely 16 by 28. Since we have not changed the fraction values in any way, we can say that the same relationship would apply to the original fractions as well. In other words, we can say that 3 by 4 is greater than 4 by 7, and this is the same result we got from the visual comparison that we did earlier on. Let us now formalize our approach for comparing two fractions. Given two fractions, the first thing that we need to do is to find the LCM of the denominators. Once we have the LCM, we need to convert each of the two fractions into their equivalent fractions with this LCM as the denominator. Once this is done, we need to compare the numerators of these equivalent fractions. The fraction with the larger numerator will be greater than the other fraction. In this video, we have intuitively examined an approach for comparing two fractions. If you like this video, please click the like button. If you have any suggestions or feedback, please leave me a comment. If you would like to be notified as and when I publish more such videos, please subscribe to my channel. Thanks for watching.